Well, hello students. This is Coach Holliday, and today we're solving radical equations. A radical equation is just a simple equation that has a square root or a cube root or something to a fraction of a power, like x to the 1/2 or x to the 2/3, something like that. And we're going to solve these exactly like you solve normal equations, like we did all year, except for at the end, when we have the square root, we're going to just square it, or if we have a cube root, we're going to cube it. So it's easy as that. We're going to do this by performing inverse operations. So for example, if I have x plus 2 equals 5, the inverse operation of that is subtracting 2. Okay, hopefully everybody remembers how to do that. If I have x times 2, then I would divide by 2. If I have x minus 2, I would add 2. If I have the square root of x, I would square it. If I have the cube root of x, I would cube it. Okay? Pretty simple there. All right. Let's just go through what the steps for solving a radical equation are. All right? The first is to get the radical by itself. That's the first step. You're going to write these in your notes. The second step is to raise both sides of the equation to the power of the radical. That's after you've gotten the radical by itself. You're going to raise both sides to the power of the radical. And then the last step is you're just going to simplify that. Once that radical's gone, you're going to simplify it and solve them like you normally do, just getting the variable by itself. Okay? So you might want to pause this for just a moment and make sure you write all those things down before we jump right into our examples. All right, if you're ready, here we go. Here's the first example. This is on your paper. And if you'll see, this is the square root of x minus 12, and that's going to equal 9. Now, the first step said for us to get the radical by itself. Well, if you'll notice, the radical is by itself. Our radical, this side, is just all the radicals, so it's all by itself. All right, the second step is it said raise both sides to the power of the radical. Now, since there's no number there, we can always write a 2 in there for our radicals. This is the square root. So what we're going to do is we're going to raise this whole side to the second power. We're going to raise this whole side to the second power. Now, when I raise a square root to the power of 2, those cancel out, and I'm just left with x minus 12. On the right, 9 squared, if you have to use your calculator, can, but you shouldn't need it, is 81. And now I'm just going to solve this. The third step is simplify and solve. So I'm going to add 12 to both sides so that I can get that x by itself. That's the inverse operation of subtraction, is adding. And I get x equals 93. And there's my answer. All right? If you didn't understand that, rewind and look back at this again, okay? Any questions? Hopefully you're good there. Let's move on to example 2. Okay, example 2, if you'll notice, it's the cube root of 2x plus 1, and that's going to equal 3. Notice the 2x plus 1 is all in that root, the cube root, and there's nothing else on that side, so this one is already solved where the radical's by itself. All right, so step 1 is already completed. Step 2 says to raise the radical to the power of that radical, or raise everything to the power of that radical. So I'm going to put parentheses around this size. I'm going to raise it, since it's the cube root, I'm going to raise it to the third power. And I got to raise the other side to the third power also. So that cube root and the cube cancel, and you're left with 2x plus 1 equals, now 3 cubed, that's 3 times 3 times 3. So 3 times 3 is 27, times 3 is 81. And now the root's gone, the radical's gone, so I'm just going to solve using my inverse operations. So the first thing is I'm going to subtract 1 from both sides, and I get 2x equals 80. And then divide. Division is the inverse operation of multiplication. So I'm going to divide by 2 and get x equals 40. And one thing I didn't do on the last example was check it. I can take this 40 and plug it in for the x and check it. So I'd say 2 times 40 plus 1. I have to take the cube root of that. So 2 times 40 is 80, plus 1 is 81. So the cube root of 81, and that's supposed to equal 3. Well, if I do the cube root of 81 in my calculator, I will get 3. 3 times 3 times 3, we found earlier, is 81. So this is correct, so it worked. All right, let's look at example number 3. All right, example 3, this one's a little bit different than the last one. It says the cube root of x plus 6 equals 2 times the cube root of x minus 1. So if you'll notice, the cube root is all by itself over here. So I can go ahead and start to solve this one. So what I'll do is I will raise both sides to the power of what that root is, 3. Now I got to raise this side to the power of 3. Now those cancel, and I have x plus 6 equals, now notice this 3 will cancel with this 3, but I also have to cube the 2. Alright, we learned this with our power rules, our exponent rules, is when I have things multiplied in here, I raise each of them to that power on the outside of the parentheses. So I have to make this 2 cubed, and then that and that will cancel each other out. So that will be times x minus 1. 2 cubed is 8. 2 times 2 is 4, times 2 is 8, and then I still have the x minus 1. And then I'll distribute that, and I get 8x minus 8, and I get x plus 6 over here. And then I'm just going to do the third step, which is just to solve this thing. Alright, so I'm going to get all my x's on the left, so I'll subtract 8x, subtract 8x, those cancel, and I get negative 7x plus 6 equals negative 8. Subtract 6 from both sides, get negative 7x equals negative 14. My last step is divide both sides by 2, and I get negative 2, not 2, negative 2, and I get x equals 7. And there's my answer. And then you could plug in the 7 and double check it all, make sure it all worked, okay? Any questions there? All right, one more example. This one's a little bit different, so make sure you follow along with it. Okay, our last example, this one looks a lot different, but it's the same thing really, okay? All right, so let's look at this. If you'll remember in our first lesson on radicals that we talked about when we were adding and subtracting, we talked about x to the 1/2 power is the same thing as the square root of x. It's actually x to the first and then the square root of it. This is our power, this is our root. So if I had x to the 2/3, that would be x squared, and you take the cube root of it, okay? But we're going to look at this part up here. Anything to the 1/2 power just means I can take the square root. So I can rewrite this problem as x plus 6, and I can make it square root instead of to the 1/2 power, minus the square root of 2x minus 4, and that's going to equal 0. Now I don't have this solved for one of the radicals, so we'll solve it for one of the radicals, and basically what I do is I just move one of them to the other side. So I'm going to add the square root of 2x minus 4 to both sides. Alright, and that leaves me with the square root of x plus 6 equals, now 0 plus that is just that. 0 goes away. This is the square root of 2x minus 4. Right, so now I've got this to where I can go ahead and raise to the second power, both sides, since it was already solved for square root, and that gives me x plus 6 equals 2x minus 4. And just solve this thing by doing your inverse operations.
Sorry, folks, a couple.
And that gives us negative x plus 6 equals negative 4. And then I subtract 6 from both sides. And that gives me negative, let's do it up here, negative x equals negative 10. And then divide by that negative 1. It gives us x equals 10. And then if I wanted to check it, I could take it and plug it in here. 10 plus 6 is 16. The square root of 16 is 4. 2 times 10 is 20 minus 4 is 16. Square root of 16 is 4. 4 minus 4 is 0. So you'd see it would come out correct. Okay? Hopefully you understood this. It seems pretty simple. But if not, just go back, rewind, listen a little bit more, and be prepared to ask any questions in class tomorrow. If you'll complete the WSQ for us and be ready to work on some problems for this in class tomorrow. And don't forget, you'll also have a K-check in class, so be ready for that over yesterday's lesson. All right? Have a great evening. We'll see you tomorrow.